have started slope and deflection of the beam. So I have decided to take a lecture with whatever resources available with me. So I used to have the blackboard right from the 10th standard. I'm using this blackboard. So just adjust with this whatever resources I have. So case number 1 and 2 of simply supported beam we already have completed. Now I am going for the cantilever. I will give expression of slope and deflection of the beam for the cantilever for the case number 1. So let us see the case number 1 for the cantilever. It is cantilever of length L carrying point load W at free end. Okay, free end. So for this particular case, now we are going to see the derivation for maximum slope and deflection. For that, let us draw a cantilever of the length L. So let this be a cantilever AB of the length L carrying point load W at the free end. Okay. So we know that what is the equation for bending moment. For that, we always take a section. So let's take a section X at the distance small x from the end B. Okay. And if you observe the deflection, the deflection will occur like this. So the maximum deflection will naturally come at B. So Y max will have at the B, and that Y max we have to find. At the end A, X will be L and Y is 0 here. So that is the known condition we have. At the end A, X is L. There is no deflection. So Y is 0. As well as there is no slope. Slope will be here. Here there is no slope. So slope is also 0 at the end A. Okay. So let us now first write the equation for bending moment. We know EI d square y by dx square is equal to total bending moment at the section X. So total bending moment at the section X is W into X. It is minus W into X because of the downward moment. Integrate this to get the slope equation. It will be EI dy by dx is equal to integration of x is x square by 2 plus C1. C1 is the constant of integration. Let it be equation number 1. Okay. What is the known condition for slope we have? Slope at the end A is equal to 0. It means at x equal to L, slope is 0. So I'll put here. At x is equal to L, slope if you take 0 in the equation 1, put it here. Dy by dx 0, x is L. So C1 is then WL square by 2. Is it? Check it. This is the value of the first constant we have determined. Put this value of C1 now back in the equation. So I am putting value of the C1. Put C1 in the equation number 1. So slope equation will be this. Put it there. Is it? Let it be equation number 2. From this we can find the slope at both ends. At B we know x is 0. So if you put x is equal to 0 at B, we will get slope. So put x equal to 0 in the equation number 2. So slope at the B will be then found. Put it here. So that will be, divide this. Put x equal to 0, first term will become 0. So what remains is second term only. WL square upon 2ER. Is it? Similarly, we can find the slope at the end A. At the end A, x is equal to L. So put x equal to L here in the equation number 2. If you put x equal to L here, simply you'll get the slope at the A, and that will come 0. Is it? Mathematically also. That slope also we denote as I. So slope at B and slope at A is found. Slope at A is 0, that is already known to us, which is used as a condition. Mathematically also it is coming 0. So slope part is now over. Now we'll move to the deflection part. Okay. So deflection part we'll see in the next video.